Good day, learners. You are welcome to this third session. But before we go into what the computer system is all about, let us briefly recall what we discussed in session 2, whereby we looked at the history of computers as well as classified computers into generations based on their underlying technology. You recall that we said the history of computers started with the invention of the Chinese abacus, which came into being around 2500 BC and went on up till the modern day of the digital computers. We also classified computers into generations, starting with the first generation, which made use of vacuum tubes as their underlying technology. The second generation, making use of transistors and diodes. The third generation, we started the era of integration, and starting with large-scale integration and heralded the use of microprocessor. Similarly, starting with the second generation, the idea of programmability, that is, being able to deploy computers to various uses, came into being, with Fortran programming language being the debut language. Then we moved in terms of programmability to the third generation high-level programming procedural languages, to the fourth generation of the usual personal computers, which made use of large-scale integration as well as microprocessors, and which were programmed with fourth generation languages, up to the fifth generation that made use of nanotechnology and artificial intelligence language as their primary programming language. In this session, we want to look at the computer system. Basically, the computer system is made up of two subsystems: the software as well as the hardware. Well, the software acts as the engine, the virtual aspect of the computer system. When I say the virtual aspect, I mean the one that cannot be seen and cannot be touched, but can only be felt. We can only feel its operations, but we cannot see it. It's not physical. Whereas the hardware is the physical aspect of the computer that we can see, we can touch, and we can move about. The hardware is therefore made up of three subunits: the peripheral devices. When we say peripheral devices, that is those devices that can be attached to the central processing unit. They can be bought off shelf and then attached to the central processing unit, and they are normally made up of the input and output devices. So when we talk of peripheral devices, we are talking of the input and the output devices. Then we also have the memory unit, and then the central processing unit, making the third subunit that make up the hardware. However, the central processing unit is made up of the arithmetic and logic unit, the control unit, and the system bus. As can be seen from the diagram, the block diagram, we notice that the central processing unit covers up to the memory unit. Yes, we have two types of memory unit. The memory unit being referred to here is the one we refer to as primary unit, which comes with the computer. However, the primary unit that comes with the computer, we also have the secondary unit as well as the tertiary unit. Both the secondary and the tertiary unit can always be bought off the shelf and added to augment the memory unit. So part of the memory unit is internal to the computer, called the primary unit, and those that are external to the computer, which can always be bought and used to expand to augment the memory of the computer, are referred to as secondary and tertiary units. In this study, we want to explain the concept of computer hardware explain the different units of a computer as well as examine the three different computer devices. These are what we will be looking at in this course: the concept of computer hardware, the different units making up a computer, and the different computer devices. Talking about input devices, they are used to provide or fetch information and instructions to the computer, and they include light pen. The light pen is used to draw directly on a computer's video screen, as well as select information on the screen by pressing a clip in the light pen or by pressing the light pen against the surface of the screen. The mouse is a pointing device designed to control the motion of an on-screen pointer or cursor. That is the rectangular blinking image that shows where the next character typed will appear. The mouse is also used to select items or choose commands on the screen. We also have the joystick, which is a pointing device that is used to navigate a cursor or other graphical object on a computer screen. The keyboard as an input device is used to type in text, numeric, and execute commands with the aid of the functional keys on the keyboard. The functional keys are the keys marked with as F1 to F12 on the keyboard. The optical scanner is used to convert images such as a picture or text into electronic signals that can be manipulated by a computer. Examples include scanning a picture into a computer and including it in a text document created on that computer. We also have flatbed scanners like an office photocopier. That is, it looks like an office photocopier. We also have handheld scanners, which is passed manually across the image to be processed. Yes, handheld scanners, the likes that are normally used by security men to scan for metals and other dangerous items worn by an individual. The microphone also constitutes an input device and is used for converting sound into signals that can be stored, manipulated, and played back by the computer. We also have a voice recognition module as an input device, which converts spoken words into information that the computer can recognize and process. Such input devices are normally used for security purposes to gain access into a particular installation by recognizing one's voice. And you will notice that some of our smartphones also have these capabilities, such that for you to unlock your phone, you make a kind of spoken word that your phone will use to identify the user and give permission accordingly. Then we have modem as another form of input device. Modem is short word for modulator and demodulator. And a modem essentially connects a computer to a telephone line or cable television network. It allows information to be transmitted to or received from another computer. And each computer that sends or receives information must be connected to a modem. Okay, so when you send applications using Xsender, you are essentially using the two phones as a sort of modem. But in this case, you are setting up a connection which we refer to as virtual. Now we look at output devices. The output devices consist of hardware that transfer information from the computer's central processing unit to the computer user, as shown below. So we have the various forms of output devices: the video graphic adapter, the printers, the plotters, as well as the monitor. All these constitute output devices. Talking about the video graphic adapter, this is a device that converts information generated by the computer into visual information called monitor that looks like a television set. So we are talking of two things there now. The video graphic adapter is the one that will convert information that is generated by the computer into the visual information that can be seen. This information, for it to be seen, will now have to be displayed on the monitor, which looks like a television set. The video graphic adapter also converts information from the CPU, which is displayed on the screen of the monitor, so that while it is converting input information to something that can be seen, like as we type on the keyboard, we are able to see what we are typing. By the time our input undergoes process, the information is also displayed for us as result on the monitor. So the video graphic adapter works with both our input as we type, as well as working with the CPU to display the processed data, which we refer to as information, to us on the monitor as well. Then we have the printers. The printers print information and graphics processed or produced with the aid of computer on paper as hard copy. Of course, there are different types of printers. We have the dot matrix, the laser printers, the inkjet printers, and other printers. Plotters also constitute a class of output devices. Plotters convert computer output to microfilm or microfiche, process information on rolls of film, as in the case of drum plotters, or slides of film, as in the case of flatbed plotters. So which means we can have drum plotters as well as flatbed plotters. Talking about storage devices, the storage devices provide permanent storage of information and programs for retrieval by the computer and consist of different types shown below. Working from the top down, we have the hard disk drive, the floppy disk drive, magneto-optical drive, compact disc, digital video disc, the so-called DVD, the compact disc, that is the CD. We also have the flash drives as well as the memory cards. One thing here that we want to emphasize is that all these storage devices that have been mentioned fall within the category of secondary devices. That is, devices that can be bought off the shelf and attached to augment the memory of the computer, which we refer to as primary memory. Hard disk drive store information in magnetic particles embedded in a disk and are permanent part of the computer. Well, of course, let us quickly say that the fact that they are classified as permanent part of the computer does not necessarily mean that they cannot be removed. They can also be removed if we want. Only that when we talk of permanent storage inside the computer, we use hard disk, since the primary storage of the computer is volatile, that is, can only be in operation for as long as the computer is on. The hard disk drive is also used to store and retrieve large amounts of information very quickly and are of different sizes. The floppy disk drives, on the other hand, are also used to store information in magnetic particles embedded in a disk and are removable. So the difference here now is, whereas the hard disks can also be removed, they are normally regarded as being a permanent part of the computer, but the floppy disk drive can always be inserted and removed at will by the user, and so they are normally referred to as removable disks. The floppy disk drives can also store and retrieve but lesser amounts of information and at a lower rates, and typically come in the size of 5 1/4 or 3 1/2 of floppy disk sizes. The magneto-optical disk drives store information on removable disks sensitive to laser and magnetic fields, and store and retrieve large amounts of information at a much slower rate. The compact disk drives store information on pits burned into the surface of a disk of reflective material, such as CD-ROM. They also store and retrieve large amounts of information like a hard disk, but at a much slower rate. The digital video disc, that is the so-called DVD, are similar to and works like a CD-ROM and can store more information, which is 15 times than that of the compact disc. The flash drives work as floppy disks but are more sensitive as a hard disk. They must be ejected logically before the final removal from the computer system and have more memory than floppy disks. So, in essence, we are saying the flash drives are in between the hard drive and the floppy drive in terms of storage capacity and in terms of ease of use. Memory cards. The memory cards work as flash drive but with a card reader. They are very effective and more durable than the flash drives. One thing we want to note in all this is that all of these output devices, except monitors, printers and plotters, may be used as input devices if they contain information to be used and processed by the user. That is, all the storage devices we have mentioned can function as both input and output devices. That is, output devices when they are stored, input devices when the stored information is being read into the computer. Then we talk of system memory. Well, system memory should be differentiated from storage devices, and that is why we added the word system and not just computer memory. And system memory refers to the computer chips that store information for quick retrieval by the CPU, and they are basically divided into two. So system memory consists of ROM and RAM. By ROM we mean read-only memory, and by RAM we mean random access memory. The random access memory, that is RAM, stores information and instructions that operates the computer's programs. They are known as volatile memory because the information within the computer chips is lost when the power to the computer is turned off. On the other hand, the read-only memory, ROM, contains information and software, that is programs, that must be permanently available for computer operation from startup to shutdown. So which means all information as well as programs that the computer will need to operate, that is, all the programs that will be directing the functions of the computer, must be stored in the read-only memory. Information such as time, dates, as well as the integrity of the memory must all be stored in ROM. And programs such as operating system, which guide the operations of the computer, are also stored in the read-only memory. And so the read-only memory is a non-volatile memory because the memory chips retain their information when power to the computer is turned off. Now the central processing unit. The central processing unit is the main brain of the computer that accepts data, performs operations on the data, and sends out the result. The main components of a typical CPU is shown below. We have the arithmetic and logic unit, the registers. Now here the registers are the memory that is being used exclusively by the CPU. The memory that is being used exclusively by the CPU, that is the one we are referring to, they constitute part of the primary memory, just part of the primary memory. And so they are faster, much faster than the primary memory, but less in storage size. Then we have the control section as well as the internal bus. So we go into each of these. The arithmetic and logic unit is responsible for performing all arithmetic and logic operations. The registers act as temporary storage areas that hold data, keep tracks of instruction, and hold the location and results of these operations. Like we did say a couple of minutes ago, the registers are for the exclusive use of the CPU. They act like the memory for the CPU, and so they are very fast, low in number and low in storage size, but extremely fast. And of course, the more the registers a CPU has, the costlier such a CPU. Then we have the control section, which is responsible for timing and regulating the operation of the entire computer system. The control system is also responsible for decoding patterns of data in a designated register and translates the patterns into activities. The control section also uses interrupt signals to indicate the order in which individual operations uses the CPU. So that is the actual control operation, to control for how long, when, and in what manner individual operations can make use of the CPU. Then we have the internal bus, which consists of network of communication lines that connects the internal elements of the processor. The internal bus also links the processor to the other elements of the computer. So which means the internal bus is like the roads that connect everything we have on the computer board to the processor, as well as linking the processor to all the other elements of the computer. So which means we will have one that emanates from the communication lines to the processor, and another line, set of lines from the processor to the computer. So which means they are bidirectional. One going into the processor, others coming out of the processor to the different elements. Now, the main functions of the microprocessor are to control the use of the main storage in storing data and instructions, that is, the use of the ROM. Control the sequence of operations, give commands to all parts of the computer system, and carry out processing. These are the main functions of the microprocessor. A bus provides a common interconnected system of circuitry that coordinates and moves information within the internal parts of a computer. When we say circuitry, we mean logic, the hardware logic. That is, the bus provides a common interconnected system of hardware logic that coordinates and moves information within the internal parts of a control. A bus is characterized by how much information it can manipulate at one time. This is known as the bus width or size, the bus size, and how quickly it can transfer this data, that is the bus speed. These are the two things that govern a bus. Now we have two types of buses. A bus can be serial or parallel. A serial bus transfers information from the CPU to an external device, such as keyboard, one piece of data at a time. Meaning that a serial bus transfers data one at a time in sequence. It is therefore slow, but provides effective connections over long distances. Since it transmits one at a time, yes, that means it may be slow, but then the connections will be more effective, especially over long distances, because they will have to be packaged in sequence, delivered in sequence. A parallel bus, on the other hand, transfers blocks of information simultaneously. That is, it transmits in packets rather than in characters, in packets. It is much faster than a serial connection, but is limited to distances of less than 3 meters, that is 10 feet, which means it is more effective only over short distances between the CPU and the external device. Most scanners and printers use this type of connections. Yes, and of course, let us quickly recall that decoders that we use to operate our television, they make use of parallel bus transfers, and that is why they have a limited range, and they have to use what we call line of sight technology, so that there is a red light that must match what is being transferred. In summary, this session examined the physical component of a computer called the hardware. The hardware serves as the structure of the computer, that is the physical part of the computer, and several components help to meet up with the specific functionality requirements, that is the input, the storage, the output, the communication, etc. You discover that the input is being handled by the input devices, the output is being handled by the output devices, both colloquially referred to as peripheral devices. Then the storage is being handled by both the storage devices and the system memory, just as the communication is being handled by the bus, either serial or parallel or both. And by this, we have come again to the end of this session.